Welcome to Excellent Grades Academy. This is Dr. Byson EM. Today we're looking at organic chemistry and we are solving tutorial sheet 1 from the University of Zambia. Okay, so without wasting much time, let's get into this tutorial sheet and solve it together. So remember, you can register for lessons on this number on WhatsApp. So if you need any organic chemistry lessons, biochemistry lessons, and any lessons in any Mate 2 course, you can register with us on +260 975 4977790. Don't forget to subscribe, comment, like, and invite your friends to subscribe to this video. Let's get into this video. Okay, so question 1. Part A says calculate the degree of unsaturation, which is the index of hydrogen deficiency in the following compounds, and suggest 2 or 3 possible structures and name the functional group. So the first one is C5H8. Okay, C5H8. Now, let us remind ourselves what the index of hydrogen deficiency is. What is index of hydrogen deficiency? So this is simply the count of how many molecules of H2 needs to be added to convert the molecule to the corresponding saturated non-cyclic molecule. So by calculating the IHD, we can tell from the molecular formula how many multiple bonds or ring structures are present in the organic compound. All right, so the degree of freedom tells us the sum of multiple bonds or rings, but does not specify exactly how many multiple bonds or rings are present. The formula that we use to calculate the IHD is 2C plus 2 plus N minus H minus X over 2. So in this formula, the C stands for the number of carbon atoms. The N stands for the number of nitrogen atoms. Number of nitrogens there. The H stands for the total number of hydrogens. And the X stands for the total number of halogens that are present in a compound. Okay, so each IHD value, the degree of freedom, has got a different interpretation, and from the value we can tell what type of structure the formula is. So now let's calculate for Roman numeral number 1, C5H8. What is the IHD for this? So the IHD is going to be, you've got 5 carbons here, plus 2. We don't have any nitrogens, so it's a 0, minus 8, minus 0, there are no halogens, over 2. When you do the math here, 2 times 5 will give you 10, plus 2 will give you 12, minus 8 will give you 4. So this will be 4 over 2. And the degree of saturations is going to be 2. The degree of saturations is going to be 2. All right, so a degree of freedom of 2, or the IHD of 2, simply means that in the compound, so this meaning that the compound can either, compound, so let's change this to compound. Compound can have one triple bond, this triple bond here, or it can have 2 double bonds. So it can have 2 double bonds, or it can have 2 rings. So it can have 2 rings, or it can have 1 ring and 1 double bond. It can have one ring, and 1 double bond. Or it can have Yes, so this is what it means. So the degree of saturation of 2 can mean that this compound has a triple bond, 2 double bonds. It can have 2 rings, 1 ring, and 1 double bond. Okay, so now considering this degree of freedom or saturation, then we can write now the possible structures for this compound. Okay, so if we write it, the first one is this. This is carbon. This is a compound with 5 carbons. So we write it. This is carbon number 1, number 2, number 3, number 4, number 5. This degree of saturation, we said that it can have a triple bond. So you can put a triple bond here. Okay, you can put a triple bond here. So you know this is carbon number 1, number 2, number 3, number 4, number 5. And this is supposed to have 8 carbons. So you know that on this carbon here, there are 2. Okay, so on this carbon here, you're going to have 2 hydrogens. On this carbon here, you're going to have 2 hydrogens. So here you're going to have 2 hydrogens. Here you're going to have 2 hydrogens. Here you're going to have 3 hydrogens. Here on this carbon, you're going to have 1 hydrogen. So if you count 1 plus 2 plus 2 plus 3, that is going to give you 8 hydrogens. So this is one possible structure for this compound. B, we said that since it has a degree of saturation of 2, it can have 2 double bonds. So you count carbon number 1, number 2, number 3, number 4, number 5. And we said it can have 2 double bonds. So double bond here, double bond here. Okay, let's count the number of hydrogens. Here you know you have 3 hydrogens. Here you have 1 hydrogen. Here you have 1 hydrogen, 1 hydrogen here. And here you have 2 hydrogens. So you add 3 plus 1 plus 1 plus 1 plus 2 plus 1 plus 1 plus 1 plus 3. That will give you 8 hydrogens. So that is balanced. Another possible structure, we said it can have 1 ring and 1 double bond. So this is 5 carbons. We can draw it in a ring. So our ring can be like this. Okay, so this can be our ring. So it has 5. Okay, so this is our ring. And then we put 1 double bond in this ring. Okay, so we know that this carbon here has got 1 hydrogen here. This one has got 1 hydrogen. This has 2. This one has 2. And this one has 2. So the hydrogens also here are 8. So these are the possible structures for this compound. We drew them just from knowing the IHD. We drew them just from knowing the IHD. So if you know the IHD for a compound, you can draw the possible structure of that compound. The other component is naming the functional groups in this compound. So the functional group here, we've got a triple bond. So we've got a triple bond number 1, triple bond. Number 2, we've got a double bond. That's a functional group. Double bond. And then this one has got is a cyclic compound with an alkene. So this is a cycloalkene. So this is a cycloalkene. Make sure to know the nomenclature or name these structures. That's very, very important. So find time to name these structures. Whenever you find organic structures, make sure you name that. Always practice, as I always say, practice naming organic compounds. So that's compound number 1. Let's go to compound number 2. So compound number 2 is this. The IHD. So the IHD for this one is going to be IHD. We know that it's 2 times the number of carbons plus 2 plus 2 plus nitrogen minus hydrogen minus the halogens over 2. So we calculate the IHD for this will be 2. They are 10 carbons plus 2. We don't have any nitrogens, so this is a 0 here. Minus the number of hydrogens here is 20. We don't have any halogens, so we'll leave it blank there. Oxygen has got no place in the IHD formula, so you leave it over 2. You calculate, this will be 22 minus 20. So 10 times 2, 20 plus 2. Plus 2, 22. Minus 20 will give us 2. So this will be 2 over 2. 2 over 2 is going to give us an IHD of 1. So we're going to have an IHD of 1 here. An IHD of 1 simply means that in this compound, we can have one double bond, or it can be a cyclic compound. So meaning there is one double bond, or it is a cyclic structure. Cyclic ring. Okay, now let's look at the possible structures that this compound can have. So this is not very visible. This is C10 H20 O2. Okay, so we can write it as a linear structure. So carbon number 1 here, number 2, number 3, number 4, number 5, number 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we said the meaning of this IHD is that they can be a double bond. So in this carbon here, we can say this carbon is double bonded to oxygen, and like this. So remember, in this structure here, we've got 2 oxygen atoms. So you find a way of putting them. So we said that this IHD, there's a double bond. They can actually be a double bond between a carbon and the oxygen. So this is a carboxylic compound. Okay, let's count the number of hydrogens we have. We know that on this carbon here, we're going to have 2 hydrogens, 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 and 3 hydrogens. When you count everything, 1 plus 2, 3, 5, 7, 9, 11. Okay, so we need to count these. Okay, so we actually put them. These hydrogens really have to amount up to 20. These hydrogens have to amount up to 20. Okay, so this is 1 here. There's no hydrogen here. There's a hydrogen 2. Okay, so 1, 2, 3, 4, 5, 6, 7, 14. 14 plus 17, 18. Where are the other hydrogens? Let's look for them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, so I left out 1 carbon here. Okay, so like this. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons. Okay, now let's count the number of hydrogens. So this is 1, 2, 3, 4, 5, 6, 7, 8. 16. 16 plus 3, 19, plus 1 here, 20. So this is one possible structure for this compound, just from the IHD. The other possible structure is that you count it linear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I can actually put the oxygen here and another oxygen here, like that. But there should be a double bond somewhere. So let me put the double bond here. Okay, so you can have an alcohol like that. Now let's count the number of hydrogens that are there. We know that this one here actually has got 2 other hydrogens, like this. So 1, 2, 3, and then here there is 1 hydrogen. Here there is 1 hydrogen, 1 hydrogen, 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. Let's count the number of hydrogens that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Where is the other hydrogen? We're supposed to have another hydrogen. Where is it? Okay, so here, there's supposed to be another hydrogen here, since we know that the carbon is supposed to have 4 bonds. So 1, 2, 3, 4. So this is where the other hydrogen is here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, plus 3, 20. So this is another possible structure. This is another possible structure for this compound. All right. So we said an IHD of 1 can also mean that it can be a cyclic molecule. Now, this cyclic molecule has got 10. So you find a way of fitting all those 10 carbons in a cyclic molecule. So here you draw a cyclodecane. Okay, so cyclodecane. When you draw it cyclodecane, then you put the oxygens there. Okay, so how can we draw it? Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, number 6, number 7, number 8, number 9, number 10. Cyclic. And then I can put the oxygen this side here and another oxygen like that. So it being a ring automatically says this one has a degree of saturation of 1. Now let's count the number of hydrogens to make sure this balances. So we know here there's another hydrogen here, and here there's another hydrogen here. Okay, here there are 2 hydrogens, 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 2 hydrogens. Let's try to count. So this is 2 plus 2. So there are 2 here, 2 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 10, 20. So this is another possible structure for this compound here. So for this compound, there are 3 possible structures. Now, what are the functional groups here? Here you've got a carboxylic acid. So carboxylic functional group. For carboxylic group, this is the functional group for the first structure. Okay, and then this functional group here is an alcohol. So this is an alcohol, this is a carboxylic group. And then this is a cyclic alcohol. Okay, so this is a decane say 1,2 diol. So this is a cyclic alcohol, and I've just written the nomenclature, the UPAC name for this structure. So there are 3 possible structures for this compound that we were given. Let's go to the third one. So the IHD for this, is going to be 2 times 7. Okay, so 2 times 7 plus 2 plus, there's 1 nitrogen here, so plus 1 minus the 11 hydrogens over 2. We do the math. This will give us 14. So this will give us 14. 14 plus 2, 16. This will give us 17 minus 11 over 2, which will give us 6 over 2. So the degree of freedom is 3. What this means that you can have 1 triple bond and 1 double bond in one structure, or you can actually have 2 rings and 1 double bond. So here you can have 1 ring and 2 double bonds. 2 double bonds, or you can have 2 double bonds and 1 ring. So this is just 1 ring and 2 double bonds. Or you can have 1 triple bond and 1 double bond. Or you can have 3 double bonds. You can have 3 double bonds. That's what this means. That's what this means. So an IHD of 3 means you can have 1 triple bond and 1 double bond, 1 ring, 2 double bonds, 3 double bonds. Or you can have 2 rings and 1 double bond. 2 rings and 1 double bond. That's what an IHD of 3 means. Okay, now let's draw the possible structures for this. So it has 7 carbons. So this is carbon number 1. Carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7. 1, 2, 3, 4, 5, 6, 7. We said you can have 3 double bonds. So you can have a double bond here, double bond here, double bond here. Let's count the number of hydrogens. Okay. So we said you can actually have, there's also a nitrogen in this compound. So you can add the nitrogen anywhere. So you can add the nitrogen here, for instance. There's a nitrogen here. So in this carbon here, I know there are 3 hydrogens. And then on this nitrogen, there's 1 here, there's 1 here, there's 1 here, 1 here, 1 here, and there are 2. Let's count the number of hydrogens. Okay. So 1, 2, 3, 4, 5, 6, 7, 10. Where's the other one? Let's look for the other one. Okay, so this carbon here has got 2. This carbon here is 1. This carbon here is 1. This carbon here has 1. This carbon here has 1. So 1, 2, 3, 4, 5, 6, 7, 10. So meaning the other one will be here, where the nitrogen is. So other one will be where the nitrogen is. 1, 2, 3, 4, 5, 6, 7. All right. So this is structure number 1. This is structure number 1. Actually, there are 2 hydrogens here. Pardon me. So meaning this side there will be 2. So this functional group here is what we call an amino functional group. So this is an amine. Okay. So this is an amino group. This is an amino group this side. So this is the functional group on this structure. B, we can say that it has 3. We say that it has 3. It has 3 double bonds, one triple bond rather. It has 1 triple bond and 1 double bond. So if I draw it like that, this is carbon number 1, number 2, number 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This nitrogen here can actually be triple bonded to a nitrogen like that. So 1 triple bond and 1 double bond. That's what a saturation of 3 means, a degree, an IHD of 3 means. Okay. So this functional group here is what we call a nitrile. So this is a nitrile. Let's just count the number of nitrogens so that we make sure that this structure balances. So there is 1 nitrogen, 1 here, there is 2, 2, 2, there is 3 here. So 3, 5, 7, 9, 10, 11. So this structure also balances. This is a nitrile. C, the third possible structure, we said that it can actually be one ring and can be 1 ring and 2 double bonds. So if I draw it to be like this, carbon number 1, number 2, number 3, number 4, number 5, number 6, and then number 7 here. So this is my ring. Okay, and in my ring there should be 2 double bonds. So the double bond here and another double bond here. Where am I going to place the nitrogen? I can place the nitrogen here. So I know that there is, okay, so there is 1 hydrogen here, there is 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, 1 hydrogen, 2, 2. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 2 are going to be here. Okay. So now, what is the functional group for this? What is the functional group for this structure? This is what we call a cyclic structure. So this is a cycloamino structure. Cyclic amino group. Why? It has an amino group here and it is cyclic. So these are the possible structures that you can have. So remember, we had 3 double bonds because degree of saturation, each double bond has got a degree of saturation of 1, 1, 2, 3. Each triple bond has got a degree of saturation of 2. So 2 here and 1, 3. And then a ring has got a degree of saturation of 1. Each double bond has got a degree of saturation of 1. So we've got 3 here. So these are the possible structures that you can write for this compound here. There are more that you can write, but these are the ones that we have come up with in this tutorial. You can go ahead and write the other ones. All right, now let's look at this structure here. Let's calculate the IHD. So the IHD for this will be 2 times 8. Okay, 2 times 8 plus 2 plus, there are no nitrogens, so plus 0 minus 10. Okay, minus 10, and then we've got, is it C12? Okay, so I don't know if this structure is okay, but it's saying it's 3 C12 here. C12, so meaning that it's supposed to be 12. Let me just look at it here. Okay, C8, H10, C12. It's correct. It's correct like that. So meaning if that's the C12 here, meaning that there's supposed to be 20 carbons there, which doesn't look very, let me just counter check and then see if this structure is very correct. Okay, so it's Cl12 actually. This is chlorine. I didn't see the L, so this is chlorine. So this is Cl2. Cl2. So we've got 2 halogens here. So we say minus 2 here because over 2. Over 2. So you do the math. 2 times 8 is 16 plus 2 will give us 18. So it's 18 minus 12 over 2. This is going to give us 4 over, so this will give us 6 actually. 6 over 2 and an IHD of 3. We know that an IHD of 3 means that there is 1 triple bond and 1 double bond. And 1 double bond. This is number 1. Number 2, there can be 3 double bonds, or there can be 1 ring and 2 double bonds, like that. So let's write the possible structures for this compound here. So number 1 can be 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there are 2 chlorines. So you can have 1 chlorine here, the other chlorine here. The other chlorine here. You know that this carbon here has got 3 hydrogens. Okay. All right. So before we count the hydrogens, we said you can have a triple bond. So you can have a triple bond here and 1 double bond somewhere. 1 double bond here. So this carbon here has got 3 hydrogens. This one here has got 1 hydrogen. This one here doesn't have any. This one doesn't have any. This has 1. This has 1. This has 2. And then this has 3. So the number of hydrogens that we have, 3 plus 1, 4, 5, 6. Okay. So 3, 4, 5, 6. So 6, 7, 8, 11. We have put, so here it's supposed to be 2 here. 2 hydrogens. Pardon me. 2 2 here is supposed to be 2 hydrogens, because this carbon here is connected to 1, 2, and the other 2 hydrogens. So 2 plus 1, 3, 4, 5, and then the other 5 here. So 6. So 10 here. The hydrogens are 10 here. What is the functional group in this compound? The functional group in this compound is that this is a halo. It has got halogens. Okay. So it has, number 1, halogens. Number 2, it has got an alkyne, which is a triple bond, and it has an alkene, which is a double bond. Okay. For B, we said that it can have 3 double bonds. So you have carbon number 1, 2, 3, 4, 5, 6, 7, 8. 3 double bonds. So you can have a double bond here with a chlorine here, the chlorine here, another double bond here, another double bond here. You know that this carbon here has got 1 hydrogen. This carbon here is 4. This has 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen, 2 hydrogens, 3 hydrogens. We count the hydrogens: 1, 2, 3, 4, 5, 6, 7, 10. Here you've got alkenes as functional groups, and you've got also halogens. The other possible structure for this one is that it can be a cyclic ring. Okay, it can be a cyclic ring and with 2 double bonds. So carbon number 1, number 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 here. Okay, and then 1 ring with 2 double bonds. So a double bond here, a double bond here, and you put your chlorine. Chlorine there, chlorine there. So you know there's no hydrogen here, no hydrogen here. There is 1 hydrogen here, 1 hydrogen, 2, 2, 2, 2. There. You count the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a cyclic compound. So this is a cyclohalogen. Okay, cyclic. It's a halo cyclic compound. So it's a halo cyclic compound. That's a functional group. If you want to name it the correct nomenclature here, this can be your carbon number 1. Okay, carbon number 1. So it can be 1,2 dichloro. So dichloro cyclo. This is octane. So oct 1,3 diene. Okay, so these are the possible structures and the functional groups that are available in this compound. So that was part A. That was part A of question 1. Let's look at question 2. Question 2 says, provide an explanation for the following observations. The boiling point of cis-2-butene. Cis-2-butene. So cis-2-butene is like this. So this is carbon number 1, number 2, number 3, number 4. Cis-2-butene means that the hydrogens are on the same side. And then so this is cis-2-butene. The boiling point of cis-2-butene is higher than that of trans-2-butene. Trans-2-butene will be like this. Carbon number 1, number 2, number 3, number 4. So the hydrogens are on different parts here. So this is the trans configuration. Now they're asking the boiling point of cis-2-butene, which this compound here, is higher than that of trans-2-butene. Provide an explanation. So the reason why the boiling point of cis-2-butene, so this is higher actually, is higher than that of trans-2-butene is because of a phenomenon that we call dipole moment. So dipole moment simply means that the electrons for cis-2-butene will be going in this direction and will be going in this direction. So the strength of the bonds, both of them will be pointing down. So because the dipole moment is pointing down for cis-2-butene, the boiling point for cis-2-butene is going to be high because there's going to be summation of the dipole moment. There's going to be a summation of the dipole moment because the bonds are stronger. But for cis-2-butene, you find that the dipole moment for this one is pointing this side, and then the other one is pointing this side. So the dipole moment is pointing in opposite direction. What is going to happen is that the dipole moments this side is going to cancel the dipole moments this side. So the net dipole moment is going to be 0. Hence, there's going to be a low boiling point because the electrons are pointing in different directions. So the reason why the boiling point for cis-2-butene is higher than that one for trans-2-butene is because the dipole moment here is high. So it has a higher or stronger dipole moment. Stronger dipole moment. For this one, for the trans, the dipole moments, so here dipole moments cancel. They are equal to 0. Okay. Now you may ask, what is a dipole moment? A dipole moment is simply a measurement of polarity of a chemical bond. Okay. So dipole moment, which is also referred to as a bond dipole. Bond dipole is just a measurement of polarity. Measurement of polarity of a chemical bond. Chemical bond. So in a cis isomer, the polarity is pointing in the same direction. So higher boiling point. The bonds are stronger. In a trans isomer, the polarity is pointing in opposite directions. So the dipole moments cancel out. Hence, they have a low boiling point. Okay. Now let's move on to B. The trans-2-butene is more stable than the cis-2-butene. Why? Explain. What is the explanation? What is the explanation? So as you can see, the cis-2-butene was like this. And then the trans-2-butene was like this. The reason why the trans is more stable than the cis is because, look at this, the electrons are flowing in the same direction in the cis. So here, there's going to be repulsion of electrons. Okay. There's going to be repulsion of electrons. So because of electron repulsion, there's going to be a lot of steric hindrance. So a lot of steric hindrance. A lot of steric hindrance, which will cause instability. So that is the reason why the cis is more unstable. It is unstable. This is an unstable configuration compared to the trans. The trans is stable. The reason why the trans is stable is because here there's no steric hindrance. The electrons here are going this side and the electrons are going this side. So there is less steric hindrance. Steric hindrance. Okay. No electron repulsion. No or less electron repulsion. Hence, it is stable. So that's why the trans configuration is more stable than the cis configuration. Let's look at the last part. Okay, now the last part says, rank the following groups in order of their priority, starting with the lowest going to the highest. So now priority is ranked. So ranking is due to the atomic numbers of the electrons of the atoms that are attached to the carbon. Okay. So here you assume that all of these groups are attached to the carbon. So this carbon, they're saying, is attached to a hydrogen, is attached to a bromine. So the hydrogen is here for number 1. It's attached to a bromine. And then the other group is a CH2, CH3. And then the other group is CH2, CH2, CH2OH. Okay. So now, if you look at all these structures or atoms that are attached to this carbon here, this is what we call a chirocarbon. Chirocarbon, or it's a chiral center. Bromine here has got the highest atomic number. Okay. So this is the highest one. Okay. Hydrogen has got the lowest, because hydrogen has got the lowest. So lowest atomic number. So this will be the lowest. So this will be number 1. This will be number 4 because it has the highest atomic number. Now when you look at this is carbon here and this is carbon, and they are all attached to the chirocarbon. Now, which one is going to be lower between these two? So this carbon here is attached to this carbon, and this carbon is attached to this carbon, and is attached to this carbon and this oxygen. So this carbon here is going to be lower than this one, because this carbon is just attached to one other carbon, while this carbon is attached to 2 other carbons. Okay, so this will be number 2, and this one will be number 3. So if I was to rank from the highest going to the lowest, it would be, from beginning with the lowest, would be hydrogen, followed by CH2H3, followed by CH2, CH2, CH2OH, and then the last one will be bromine. Okay, so this is the answer. Let's go to the second one. The second one, so the chirocarbon will be here. And then on the chirocarbon, you've got an OH, which is attached, which is this group here. And then the other group is this one here, CH2. All right. And then this CH2 is attached to an OH. The other group is this one. You've got C. Okay. And this C has got an attached O here, and that there's an attached OH, which is this group here. And then the other one is this one. You've got a C here. It has an attached OH here, and it has O and a methyl, like this. So the highest atom that is directly attached to this chiral center here, chiral center, is this oxygen. So oxygen will be number 4. It is the highest. But the other ones, the other atoms that are directly attached to the chirocarbon is this carbon here, this carbon here, and this carbon here. They are the same. Now, you find that this carbon here is attached to one other carbon. But this carbon is attached to two carbons, which is this one here and this one here. And this carbon is attached to two oxygens rather, which is this oxygen and this oxygen. So this one will be the lowest. So this will be number 1 because it is lower than these 2 other carbons. This carbon is only attached to this oxygen. Let's now compare this carbon and this carbon. This carbon here is attached to this oxygen, whilst this carbon is also attached to this oxygen. So this oxygen goes. This carbon is attached to this oxygen. This carbon is also attached to this oxygen. So they go. The other atoms that this carbon is attached to, you've got a carbon here, whilst this other one is only hydrogen. So the carbon is higher than the hydrogen. So this one becomes number 2, and then this one becomes number 3. So in ranking, you're going to have this one here will be number 1. So this carbon here will be the lowest, followed by this carbon here, which is COOH, followed by COOCH3, and then followed by the OH. The OH will be the highest. So this is the ranking. Okay, let's go to number 3. So these are the groups that are attached. You've got a chlorine here, then you've got a bromine here, then you've got a C here, CH2, that is attached to a bromine, and then you've got a CH that is attached to a chlorine. So now, which one is the highest? You know that bromine has got a higher atomic number compared to chlorine, so this will be the biggest, number 4, followed by chlorine. So carbon, this is carbon. So this carbon is attached to chlorine, this carbon is attached to bromine. So this carbon is attached to these two hydrogen cancel because they are the same. So between bromine and chlorine, which one has got a higher atomic number? It's bromine. So this one will be the lowest, followed by this one here. So this is the lowest because this carbon is attached to chlorine here, which has a lower atomic number compared to bromine. So this is number 1, number 2, number 3, number 4. So in assigning priority from lowest to highest, you're going to have CH2Cl followed by CH2Br followed by Cl, and then the bromine is going to be the last one. Okay. Now let's look at the last one. So these are the groups. This is your chiral carbon. Then on your chiral carbon, you've got this chlorine here. This chlorine, this carbon is attached to 6 carbons. Okay. So it's 6 carbons. So it's attached to 1, 2. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And it has 5 hydrogens. With 5 hydrogens. This is one group. And the other one is this one here. This one is saying this chlorine is attached to this hydrogen, and then it's attached to these methyl groups. This one here and this one here as well. The other one, so this one is the one I was from writing. This one is this one here. The other one is this here. So the other one is this here. So this here is simply this hydrogen, this carbon has got 3 methyls. It has got 3 methyls like this. And then the other group is this one here. So this one just has a hydrogen and it's triple bonded to. So you're comparing 1, 2, 3, 4, 5. So it's not conventional for carbon to have 5 bonds, but since we're comparing 5 bonds, let's just write this one this side. So this one is just carbon attached to 2, and then this one like this, like that. So you're comparing group 1 here. This is group A. This is group B. This is group C. This is group D. And then this is group E. Let's now assign priority. Okay. So now all of these are carbons. So this carbon here is attached to this carbon. It's also attached to this carbon, to this carbon, this carbon, this carbon. It has the longest carbon chain. So this one would definitely be the last one. So this would be number 5. Now let's compare the other ones. This carbon, okay, is attached to this hydrogen. And it's attached to this methyl here. Okay. This methyl, and it's attached to this methyl. Okay. So now we start comparing. And then this one, this carbon here is only attached to this hydrogen and this other group here, which is a C and an H2. So you're going to see that C is going to be the one of the lowest carbons. Okay, it's going to be one of the lowest. Okay, so this one here, this group here is attached to hydrogen. This C here is attached to hydrogen and a carbon. This one is attached to a carbon and a hydrogen. So between these two, this one will be the lowest. So this will be the lowest, and then followed by this one here. Okay, why? Because this carbon is only attached to one carbon, and this carbon is also only attached to one carbon. But this carbon here is higher than this carbon because this carbon has got two hydrogens, this hydrogen here and this hydrogen, whilst this carbon here only has one hydrogen. That's why this one is higher than this. Now let's compare these two. This carbon here is attached to this. This is also attached to this, so they can cancel. This is attached to this. This is also attached to this. This is attached to a hydrogen here, but this one is attached to a carbon here. So meaning that this one is higher than this. So this will be number 3, and then this will be number 4. So in assessing, in ranking priority now, you're going to have from the lowest, C will be the lowest, followed by E, followed by B, followed by D, and A will be the last one. So remember, this is A. We said this is A, and then we said this was B here. This is B, and then this is D, and then this is, where is C? Okay, this is C, and then this is E. So in ranking priority, you've got C as the lowest, and then you go to E, then B, then D, and A. So this is how you're going to rank priority in this compound here. All right, so that was the end of question 1. Okay. For question 2 and question 3, there's another video that is coming. Stay tuned, subscribe, and let's solve organic chemistry together. Always remember that lessons are ongoing and subscription fee is only 100 kwacha per lesson. If you want to access the solutions for the entire tutorial sheet and all the tutorial sheets that are going to come out in organic chemistry, you can pay the subscription fee to our YouTube channel, and we'll open all the videos for your lessons. Okay, see you in the next video. Subscribe.